So, right. So we have, for example, this one, the limit is 0. But if you check the partial sum of this series, the series is actually diverge. Okay, let's see this one. Let's say for S of 1. So S of 1 meaning what? Meaning this is only the first term. Okay, so this is n goes to 1 to infinity. Okay. Okay, so S of 1, this is just 1 over 1, which is 1. Okay, and then if we have S of 2, the sum of two terms, it will be 1 plus 1 half. Why? Because the first term is 1, and then the second term is 2. So this is 1 over n is 1 over 1 plus 1 over n, 2. So 2. And then if I have S3, I have 1 plus 1 over 2 plus 1 over 3. Okay. S4, why I did like this? Because I want you to see the pattern. So 1 over 4 is 1 plus 1 over 2. We try until 4. Plus 1 over 3 plus 1 over 4. Okay. So I think that we can do like this. Let's choose this one. Let's choose Y. Let's choose this part. S2 and S4. Okay. Okay. And then we can compare with some value. Okay. Kalau saya compare, so if I compare this, S of 2, this is just S of 2 to the power of 1. Okay. S of 4 is just S of 2 to the power of 2. Sebab apa? Sebab saya nak, because I want to take this base. Sebab dia akan jadi senang sikit kita nak buat comparison. Okay. So kalau dalam case ni, S of 2, this is bigger than S of 2 to the power of 0. Okay. Sebab apa? 2 to the power of 0 is 1. This is equals to 1. So S of 1. Sebab apa? 1 plus 1 half is bigger than 1 because you have extra 1 half over there. Okay. And then kalau saya compare juga, S of 2, this is obviously bigger than. So kalau saya buat perbandingan, saya nak cuma ubah dia punya ni saja, this term, supaya saya akan dapat 1 over, it's not 1, 1 plus 1 over 2 plus 1 over 4 plus 1 over 4. Okay. Betul ke tak? Dia lebih besar. Betul? Sebab apa? Sebab dia punya term kat sini 1 over 3. 1 over 3 is bigger than 1 over 4. Because why? 1 over 3 dia 0.3333, tapi 1/4 dia adalah 0.25. So, cuma tambah sikit saja, dia lebih besar. Okay, so kalau saya work out on this part, on the right hand side, saya boleh buat. Okay, so this is S of 2 is bigger than, saya simplify, 1 plus 1 half plus 1/4. 1 over 4 plus 1 over 4 is 1 over 2. Okay. Okay, so nampak tak dia punya ni? So this is like 1 plus 2 over 2. Saya tak nak ringkaskan lagi sebab apa? Sebab nanti awak akan nampak dia punya pattern dia. Okay, so maksudnya saya boleh kata this is 2 power of 2. As the partial sum for 2 to the power of 2 is bigger than 1 plus 2 to over 2. Kita nak buat apa ni? By induction. Kita nak buat proof by induction yang menunjukkan bahawa 1/n tu adalah the series of 1 over n is divergent even though the limit of un is 0. Okay, let's try. This is 2. Let's try S3. Now S3, S2 to the power of 3. S2 to the power of 3. So maksudnya this is like S8. Okay. So meaning that you have 1 plus 1 half plus sampai ke 1/8. Okay. So saya nak guna benda yang sama. So yang untuk kedua ni dia kalau kat sini dia akan ada apa? Dia akan 3, 4, 5, 6, 7, 8. So kalau saya nak tukar balik kepada ni, saya boleh buat. Saya nak buat dia punya perbandingan. Okay, so 1 plus benda yang sama untuk S2 over 2 plus 1 4 plus 1 over 4 plus, so yang apa ni? Yang ni 2, 3, 4. So 5, 6, 7. Semua saya nak buat per 8. Okay. 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8. Okay, so maksudnya kalau saya nak buat perbandingan, mungkin saya boleh tulis dia punya the full expression. If I write the full expression right here. So it will be 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, 5, 6, 1 over 7. Okay. So you can see that if you compare the terminology, the term right here, this one is bigger than 1 over 4. Okay, 1 over 4, that's equal. 1 over 5 is bigger than 1 over 8, obviously. 1 over 6 is bigger than 1 over 8. 1 over 7 is bigger than 1 over 8. So that's the comparison. So that's why I have this bigger than. This sebab tu saya ada kat sini. This is bigger than. It's not even equal. It's much bigger than. Okay, so maksudnya apa? So maksudnya S of 2 to the power of 3 is bigger than. So yang ni apa dia? This part is the previous one. 1 tambah 1 per 2 over 2, right? Okay, plus also included this one. Okay, so we have how many of this? So we have 4 over 8. Okay, so I just do it slowly because I want you to see. Okay, so this is 2 over 2 plus 2 over 2. 4 over 8 is 1 over 2. So this is equals to 1 plus 3 over 2. So S of 2 to the power of 3 is bigger than this one. And you can do the whole thing by induction. So by induction, you can see that, you see this one is 2. This one is 2. Let's use another color, maybe green. Okay, this one is 2. You have 2 right here. And this one is 3. you have 3 right here. So by induction, I can say that I can safely say that s of 2 to the power of n is bigger than 1 plus n over 2. Okay, so if I take the limit to see this, if the partial sum is converged or not. So if I take the limit, on this partial sum as 2 to the power of n. So if I take limit, n goes to infinity, for s 2 to the power of n, this is equals to 1 plus n over 2, it goes to a positive infinity. So in this case, s n equals to 1 over n is diverges. Diverges, but you can see that limit of n goes to infinity for un. What is the un? This is the term, the nth term. Okay, this is the difference between un and the summation, partial sum. But the limit is 0 because 1 over n, 1 over infinity is 0. You get almost 0. So in this case, you can see that the vice versa is not true, even though the limit of un is 0. Okay, so you need to remember this one because this is called p series. Let's see this one. Okay, and so we have, what if we have more than 2 series? Let's say theorem. Okay, let's say we have un and then a series of vn, and both are convergent. Both are convergent. And if you want to add, if you want to do some arithmetic calculation, let's say if you have summation of c of u of n, so you can take c out, u of n. So c is any constant. C is any constant, arbitrary constant, as long as c is defined. Okay, so you can do the same thing that you did in algebra, which is you can take any constant multiplier, take it outside of the summation. Okay, the same thing if you have the summation of u n plus minus the series of vn. Okay, so you can also do it separately. So in this case, this is, what do you call it? Distributive. This is not distributive. Properties in algebra. So plus minus vn. Okay. So this is one of the properties in linear part, not linear algebra, but this is the properties for linear operation. That's the word that I want to say. So linear operation, you can do something like this. Okay, and you have, for example, summation of a of un plus minus plus, I think it's plus is better, b of vn. Same thing, you can take a outside of the sum un plus b outside of the sum of vn. So provided that both are convergent. The proof, I will let that just leave it to you to try. Okay, let's see this one. Examples. Example, if I have show that so meaning that if you have separate, you can also see some pattern 1 over like odd term and then even term, alternating series. This is applicable to any series. Okay, show that I have 1 over 3, 1 over 1 plus 1 over 3 plus 1 over 6 plus 1 over 10. I want you to see the pattern. Plus 1 over 15 plus 1 over 21 plus something. So this series equals to 2. Okay, so let's see what's the pattern of this one. Okay, you can see that this is the first term. Ini term yang pertama. Second term, third, fourth, fifth, sixth, and so on. Okay, so you can see that this is like 1 over 1. Okay, so and then this one is like 1 over 2 plus 1. So this is like, I just want to write the denominator of that. So this is just over 1 over 1. This is 1 over 2 plus 1, the third term. And this is like, what was that? 3 plus, this is 2 plus 3 plus 6 plus 1. So this is like 2 plus, I think I can write in this manner. 1 plus 2, and then this is like 1 plus 2 plus 3. Okay, can you see the pattern? This is just add everything. So this is like 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4. So you can see that it adds the term. So this is n plus 1, n plus 1, n plus 1. So this is, if you can go to a formula, you can see that this is just 1 over n times n plus 1 over 2. That's the formula. So this is just, so you can see the general formula. So the general formula will be 1 over n plus 1. 1 over n plus 1 divided by 2. Okay, I will let you just check the formula. Just give it. You can try check on your own. Betul ke tak? So let's see this one. So that's equal. Try plug in. Check by your own. Check yourself. Check yourself that this is the general term for this series. So I can say that the Sn, the partial sum of this is equal to 1 plus 1 over 3 plus 1 over 6 plus 1 over 10 plus 1 over n plus 1 over 2. Okay, so Are you guys with me so far?
Yes, Doktor.
So
Yes.
saya cuma nak ambil dia punya ni saja. Saya cuma nak ambil dia punya general formula. Okay, kalau dia agak mungkin awak tak nampak lagi, tapi tak apalah, buat dulu. Untuk dapatkan general formula tu mungkin awak cuba try more exercise. Okay, so kalau tengok kat sini, I want to get rid of this over 2. Okay, saya nak get rid of that over 2. So saya saya boleh everything will be divided by 2. Okay, so kalau saya get rid of that, saya akan dapat 1 over 2 Sn equals to, so divided by 2, 1 over 2 plus 1 over 2 times 3, 1 over 6 plus 1 divided by that it will be 4, mana tadi dia punya ni? 6 kali 2, 12. 1 over 12 plus 1 over 20 times 2 plus, and then this will be 1 over n times n plus 1. Jadi saya nak get rid of this. So, dia punya formula kat sini, saya darab dengan 1/2. Everything is multiplied by 1/2. So saya akan get rid of over 2 over there. Okay, so tujuan dia apa? Jangan ni nak kan terlupa pula apa tadi? Kita nak pastikan yang dia punya partial sum, the limit of the partial sum is equals to 2. Okay. So kalau saya rasanya kita dah ada jumpa benda ni sebenarnya sebelum ni. Kan, dekat dengan sequence. This is from your sequence. Sequence term. Kalau awak ingat lagi, daripada sequence yang atas-atas tadi, atas ada kat sini ke tak ada? Saya mana tadi? Mungkin dekat sequence. Saya nak cari, rasanya ada. Okey. Oh, yang tadi, yang 1/2 ni. Okey, so rasanya ada. Hari saya pernah bagi tahu. 1 over apa dia tadi? Tak ada. Somewhere. I think I told you somewhere. Yes, this one. Yang ni. Okay. So kalau awak ingat yang ni, 1 over sama juga tadi. Yang tadi cuma n, yang ni adalah k. Okay, kalau awak tengok kat sini, awak boleh buat expand into partial fraction. Okay, sama juga dengan yang ni. So yang 1 over n times n plus 1 ni expand into partial fraction. Okay. Mungkin awak tak ingat je. Saya remind balik. Okay. So yang ni kita boleh expand into partial fraction. Okay, so bila kita ambil balik yang kita buat semua ni, okay, yang mana tadi yang ni, okay, so dia adalah Sn adalah 1 tolak 1 1 over n plus 1. Okay, so kita dah buat sebelum ni sebab tu saya tak explain. Okay, so we can see that the series is just, so this is Sn is just 1 minus 1 over n plus 1. So, kena ingat, before that saya terlupa. This is not Sn, this is Sn over 2. So this part is equals to that. Okay, so maksudnya apa? So kalau saya ni multiply by both by 2 and then right hand side also multiply by 2, saya akan dapat Sn equals to apa dia tak boleh pergi ke kanan? Itu tak ada. Tak boleh. Okay, peringat ya, kena okey. Saya tak jumpa dia punya ni. Dia nak pergi ke kanan. Okey. Okay. So yang ni. So this is the 1/2 Sn. Okay, so the expanded into partial fraction, and then Sn is just 2 minus 2 over n plus 1. Okay, so kalau kita ambil limit, take the limit, n goes to positive infinity of 2 minus 2 over n plus 1. So yang ni obviously goes to 0. This is equals to 2. So we can show that Sn equals to 2. For this one. Apa dia tadi? Tadi. This series. When n goes to positive infinity. Okay, ada soalan? Kemungkinan dia apa dia ni? Kemungkinan awak dia series dengan sequence ni dia banyak sikit, banyak benda sikit. So benda yang lepas tu perlu dikenang, jangan tak dikenang. Barang yang lepas awak kena ingat balik. Sebab dia ada kaitan antara sequence dengan series, dan dia kalau awak tak ingat satu benda, selepasnya tu agak susah sikit. Alright. Okay, let's see the series. Let's see this series. 1 over, let's say, show that the series (1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus this is less than 2, strictly less than 2. Okay, first thing, mula-mula sekali, apa nak buat? Try to find the formula. Okay, try to find the formula. So yang ni nampak mudah je lah kan, sebab kalau awak tengok kat sini, so the first term is 1 over, let's use red marker. So the first term is just 1 over the first term. The second term is just 1 over 2 factorial. And the third term 1 over 3. So it means that my general formula for this series for un is just 1 over n factorial. Okay, 1 over n factorial. And n goes from 1 until positive infinity. So starting from 1 until positive infinity. Okay, did you recognize this series? Okay, kalau awak ingat, kita buat tentang exponential hari tu. Let's see, let's go back. Mana exponential? Saya nak cari exponential. Okay, kat sini. Okay, so awak ingat lagi tak dia punya ni? Saya replace, this is for exponential. Okay, so kalau awak tengok kat sini, dia macam ada sikit-sikit dengan exponential, tapi exponential dia ada extra term kat sini. Kalau awak tengok dia extra term dia 1 tambah 1. So dia macam 0 factorial. Okay, so kalau dalam kes ni, saya bikin cepat sikit. So kalau dalam kes ni, case series, if you remember, we have E. E apa dia? E is just the summation of K equals to 0. Saya nak buat sikit. Saya nak padam sikit. So, E is just what? 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 plus and so on. Okay, nampak tak apa beza dia? E dia punya nilai dia apa? E nilai dia, the value for E is 2.71 something something something. So obviously dia lebih daripada 2 sebab apa? Sebab dia ada this term kat sini. Not that, not the whole thing. Okay, so dia ada extra kat sini. So if you compare this to this, okay, so this term is just, let's say, kalau saya panggil ni sebagai Sn, so this is just Sn equals to 1 plus 1 over 2 factorial plus something. So this is just equals to apa dia? E minus 1. So this, if you take the limit, saya ulang balik sebab saya punya cara tulisan ni okay. So if I take the limit n goes to infinity for Sn, okay, so this is just equals to E minus 1. Why? Because Sn is equals to summation from n equals to 1 to infinity for 1 over n factorial. Okay. Dan untuk E is just summation from n equals to 0, 1 over n factorial. Okay. Dan awak kena ingat, apa ni, 0 factorial is equals to 1. So saya rasa awak dah pernah jumpa ni kan, 0 factorial. 0 factorial dia sama dengan 1. Dia ada pembuktian dia, kalau awak berminat nak cari dia punya bukti, silakan. Okay, so dia cuma extra satu term sahaja. So maksudnya apa? So E tu apa? E is 2.71 something something something. So obviously you can see that this is less than 2. So sebab dia ada cuma extra 1 sahaja kat situ. Dia start daripada kosong, yang ni start daripada 1. Okay, any question so far? Ada soalan setakat ni? Okay, tak ada. So kalau tak ada, kita teruskan dengan convergent test. Convergent test pun dia ada beberapa convergence. Convergent, GENC. Okay, so dia ada beberapa convergence test. Yang pertama kita ada comparison test. Yang kedua kita ada limit test. Dan yang ketiga kita ada summation test ataupun integral. Okay. So kita boleh buat 3 ni. Alright. Contoh. Dia punya ni teorem yang pertama. Kita akan buat sesuatu comparison dulu, and then set limit, and then dia limit dengan comparison test ni dia lebih kurang sebenarnya. Dan satu lagi, saya lupa lagi. Yang keempat kita ada ratio test. Okay. Dan dia ada kaitan dengan antara tiga ni. Kalau kita tak boleh buat comparison, kita boleh buat limit. Kalau ratio test pun kita ada dalam comparison, dan last sekali kalau paling susah pun kita boleh buat integral. Kenapa kita buat integral? Sebab awak kena ingat yang summation tu, the series is a summation. So bila kita kata series as a summation, kalau awak tengok dekat dia punya summation notation tu, dia ada lebih kurang dengan integral definition. So sebab tu dia ada, kita boleh guna integral test. Okay, P series theorem. Okay, P series is convergent if P is bigger than 1, and divergent if P is between 0 and less or equal than 1. Apa maksudnya P series ni? So P series is just summation from n equals to 1 to infinity 1 over n to the power of P. Okay, last time kita check if P sama dengan 1, if P equals to 1, so meaning that the series is summation for 1 over n, and from 1 to what? To infinity. So let's say this one is, we already did before, I think just now, right? Yes, just now. Just now kita dah buat 1 over n is not convergent series. So 1 over n to the power of 1 is not converged. You can see that Sn diverge even though the limit of un is 0, because the limit is undefined. Okay, so this one is not converged. How about P equals to 2? So meaning that n equals to 1 from infinity 1 over n squared. Okay, so by this theorem, this series is convergent. Okay, why? Kita akan guna this. This will be proved in using integral test. Okay, saya tak nak sentuh lagi, cuma you just take as it is. Terima saja untuk setakat ni. Kita akan tunjuk how to prove, but for this time, at this time, just accept this fact that if P is bigger than 1, 1 over n to the power of P is converge. Okay. Kita guna comparison test dulu. Okay. Comparison test example. If you have any question, just let me know. Don't be quiet. Okay, let's say if UN and VN is positive I think I need to positive term series. Maksudnya every term in the series are positive, so bigger than 0. Okay, what's the comparison test? Okay, let's see. If number 1, if the series of Vn converges, and we have Un, the nth term of Vn is less than that for all n. Therefore, we can say that the series of Un also converges. Because why? Because this one is converged, the bigger one, the big guy is converged. So automatically the smaller guy also converge. Anything because the big guy is. All right, number 2. What happened if summation of Vn, the series of Vn diverges? And you also have Un is bigger than Vn for all n, meaning that the term is bigger. For each term is bigger. And we can say that the series of Un also diverges. Because why? Because you can see that the smaller guy diverge, and so does the big guy. Okay, that is the comparison test. Number 1, comparison test number 1. And we can also compare using the limit test. Okay, and Un is the same thing. Un and Vn are positive. Remember the positivity of that. Okay, so we can do something like number 3. Number 3, if we take the limit as n goes to positive infinity, Un over Vn, this is equals to any constant a, and a is obviously positive because why? Because this is a positive term. Un and Vn are positive term. Okay, and a is finite number. It's not infinite. A is finite. Okay, so you can see that either both diverge or converge. You can do that also. So dua-dua boleh converge, dua-dua boleh diverge. What if it's equals to 0? If A is equals to 0, no conclusion. Isn't that 0 is a really nice number? Okay, let's see some examples. Check check the behavior of the series below. Okay, bila dia kata check the behavior, maksudnya kita nak check ada beberapa kemungkinan. Okay, kalau dalam in sequence, if you want to say about the behavior, you can say is it increasing or decreasing. Okay, so you want to check the monotonicity of the sequence. And you can also say, is it a diverging sequence or converging sequence? So you have extra thing for sequence. And for the series, if I say, if the question asks, check the behavior of the series, meaning that there's only two things. Is it going to be converge or is it going to be diverge? So that's the only behavior that you want to check for series. For sequence, you have some other term, some other explanation. Okay, what's the series? So the series is, it can be, even though you didn't have, I didn't put any limit on the sigma notation, it means that n start from 1 to infinity, even without the limit explicitly stated. Okay, so n over 2 times n squared minus 5. Okay. So this looks like a p series. So p series can be any, in some textbook it says some other series, but in most cases this is a p series. All right. So you can see that this looks like p series. Okay. Let's take out the constant term and then try to use comparison test. Okay, n over 2n squared minus 5. So this one is bigger or equal than n over 2 times n squared. Why is it bigger? Because this one has less 5 and compared to that one. So the denominator is smaller than this one. Okay, so if I cancel out n, this one, so this equals to 1 over 2n. So if you remember, if I say something like this, so let's say this is equals to Vn. Okay, so Vn is equals to 1 over n. So if you remember that 1 over n, Un equals to that, and then Vn is equals to that. Okay, you can see that if I compare left-hand side, and then the right-hand side, okay, if I compare that, I can see that Un is bigger than Vn. Okay, now let's check the Vn. Vn equals to 1 over 2n. So this is the nth term for Vn. So for this one, okay, the series, so the series will be 1 over 2n. So this is the series 1 over 2n. So this is equals to 1 over 2 times 1 over n. Okay, this series, you can take the constant factor out of the sigma notation. So this series is diverge. Because why? P equals to 1. Divergent P series. P equals to 1. If you remember what we said just now, this is the P series. Where's the P series? Right here. Okay. And you can take the constant out. So this is divergence. So we can say that since SINC, since Vn diverges and Un is bigger or equals than Vn, so I can say therefore Un also diverges. So this is the conclusion from our comparison test. So we compare left and right. Okay, now let's check another one. Summation for 5 over 2n squared plus 1. Okay, now you can see that this you can compare with 1 over n squared. Okay, so if I put something like this is equals to un. Okay, so un is just equals to 5 over 2n squared plus 1. So this is less or equals than 5 over 2n squared. Okay, because why is it bigger? Because the denorm for un is bigger. So that's why this is less. And that this is equals to Vn. Okay, so if you do a calculation for Vn, okay, so Vn is just 5 over 2 times 1 over n squared. So in this case, you can see that the series 5 over 2, 1 over n squared is equals to 5 over 2 is equals to that. Okay, so in this case, this part is convergent P series. So because this one is a finite number, you don't have to worry about 5 over 2. This is a finite. Okay, so we can see that un, you can say Vn is apa macam mana saya tulis tadi? Since Vn converges and un is less than Vn, so therefore un also converges. All right, you can also check the ratio test. You can also check this one. Check the ratio test. You can check the limit test of the ratio of un and vn, that this is equals to 5 over 2, which I'm not going to do that. So if you check also limit n goes to infinity for un versus vn. Okay. it will give a positive definite value. Okay, one last example, I think. How about this one? I think maybe we can take 5-minute rest. Okay, so this because it's already 12. Okay, so take 5 before we go for the last comparison test. Okay. So I can give you one example, but you need to think on your own. For example, this case, if you have this one, another one, another comparison test. For example, if I have summation of n squared over n cubed plus 2, my hunch will be that this one is divergent series. Okay, why? Because you can see that n squared, you can compare with n squared over n cubed. So n squared over n cubed is just 1 over n. So just take this one, just do something like this, n squared over n cubed plus 2. This is much less than n squared and n cubed. So you can see that this is that much. All right, how about this one? Let's say this one. Test for convert test. The series of 1 over 2 to the power of n minus 1 converge or diverge for convergence. Convergence or divergence. Sorry, tulisan saya dah macam dah lari dah. Okay, let's see this one. So if I say, if I divide into 2 parts, if I say AN is the original series, which is 2n minus 1. And then I say Bn is 1 over 2n. Okay. Do we have the p-series test in this case? No, we don't have that one. But in this case, we can also use the limit test. Okay, so we can try to look at the limit comparison test. But actually this one is what? This one is like 1 over r something, right? So this is geometric series actually. Geometric series. Okay. So we can see, let's test. Take the limit of n goes to infinity. So n is u, b is v. So an over bn. Limit of n goes to infinity of, what's that? So if you divide that, it will be 2n over 2n minus 1. Okay, tahu tak kenapa jadi macam ni? Saya ringkaskan ni. Saya ringkaskan daripada step apa dia? Step dia adalah I'm sorry, I think that Oh, saya rasa ni sikit, rasa pening sikit. Okay, apa dia tadi? 1 over 2n minus 1 divided by 1 over 2n. Okay, so this one is just, you just flip the order, so that's why you get this one. Okay, so you can see that when n goes to infinity, this is like infinity over infinity, so this is indefinite form. And if I divide into the whole thing by what, by 2 over n, so the upper part and then the lower part also divide into 2 over n to the power of n, so it will be limit of n goes to infinity 1 minus 1 minus 2 minus 1. Okay, so in this case this is equals to 1, which is a positive. Okay, so since this is a finite and positive, this is finite and positive, so you can see that this one is what, this one is either converge or diverge, so it has a conclusion. But if it's equals to 0, you cannot say anything about that. Okay, so what we can compare now, the next step is we can compare for an, is it bigger or less? Actually, if you can see that this is a -1, so it will be less than bn. So all you need to check is check that the series of 1 over 2 to the power of n, this is actually a convergent series. Because why this is a convergent geometry series? I think we did that before. I don't want to repeat. Last time, where did I put that one? Let me try to remember. Let me try. I think this one, right? Oh, this is sequence. Let me see. Let me try to show you. Okay, so we show you that this, you have two series, geometric and arithmetic. Okay, you can see that if the ratio, okay, so the ratio is, it will be converge or diverge. So you can see that 1 over, just try to manipulate that. I'm really sorry. Saya tiba-tiba saya pening. Kalau awak nampak saya rasa macam saya ni. Oh. Okay. So you can check mana tadi? Sorry, saya dah ter itu tadi. Mana tadi? Tadi. Alright. This one. Okay. Okay, well, just check this formula. This formula, a is not 0, and then this is k is okay. So in this case, k is minus n. You can see that this series that we did just now is convergent. So this one is convergent, and therefore, since b is convergent, a is also converge. B and converge, and so does Yeah. One more example. I think I need to, yeah. Okay. Tak apa. We can do 2 examples and then I think I have to stop because I don't feel good. Sorry about that. Okay. Let's see one examples. One of the 2 examples. Okay, let's see the one. Determine examples. Determine the series. Determine whether the series converge or diverge. Okay, what's the series? So this is from 1 to infinity, 5 over 2n squared plus 4n squared, 4n plus 1. Okay. So what's the conclusion for this one? The same thing that you do for your calculus 1. So if you think that find the dominant part. So you need to find the dominant term, which is 2n squared. Okay, so the dominant term is 2n squared on the denominator. So you can see that if you compare, this is 5 over 2n squared plus 4n plus 1. So this is less or might be equals to 5 over 2n squared. All right, so same thing. If you can see that this looks like a P series. P series and P equals to 2. So the right hand side converge, and so does the one that is less than the right hand side. So therefore we can see that this series converge. Okay, you need to write the whole thing, but this is what my conclusion is. You can write. Tolong sila tulis dengan dengan sempurna. Saya tak nak tulis dengan sempurna. Okay, so just look at the dominant term. Kalau dominant term dia kuasa 1, so maksudnya P series ni adalah diverge. Okay, let's see one last example. Hari ni kita buat comparison test saja. Okay, let's see example. Sampai muntah buat. Okay, let's see the series of 1 over 1 plus 1 over n and n squared. Okay. So yang ni pun rasanya kalau awak tengok benda yang macam ni, awak dah dapat agak. Kemungkinan saya kena guna comparison test. Walaupun mungkin nanti nanti bila kita dah try semua method untuk tengok dia punya converging or diverging series. Okay, selalunya kalau tengok je macam ada fraction, kemungkinan kita perlu guna comparison test. Sebab dia punya apa ni, kalau fraction tu senang kita nak compare mana lebih besar dengan mana yang lebih kecil perbandingannya. Kalau tak boleh guna comparison test, ada kita tengok next topic. Okay, so apa kita nak buat? So what to do about this? If you expand, take this one, take the denom, this one. All right, so I can say this is equal to 1 over 1 plus 1 over n and n squared. So if I expand this, this is also equals to 1 plus 1 over n to the power of n. Okay, and then this is to the power of n. Okay, have you seen this form somewhere? Ada pernah nampak tak form ni dekat mana? 1 per this one, this. Saya pernah nampak dekat yang sebelum ni. So nanti awak tengok balik dia punya nota. Okay, if you see that this is this is bigger than 2 to the power of n. Okay, kalau tengok dia, kalau awak perasan dia macam series ni dia apa, dia macam ulang balik. Cuma awak kena ingat dia punya form tu macam mana. Okay, so kalau tengok kat sini dia macam exponential series tu. EXP. Okay. So maksudnya kalau saya reverse yang ni, divide left and right. So divide left and right. So maksudnya divide by 1 over something. So 1 over 1 plus 1 over n to the power of n to the power of n. So therefore this one is less than 1 over 2 to the power of n. Okay, so what can you say about this? Same thing, you can see that the series, this is a geometric series. This guy is convergent geometric series. Summation of 1 over 2n is convergent geometric series. Therefore, the series of 1 over 1 plus 1 over n squared also converges. Okay, any questions so far? So hari ni kita cuma buat ni saja, comparison test. Okay, so you can see that dia ada beberapa series yang kita buat sebelum ni. Contohnya tadi, yang ni kan, so awak ingat tadi, yang ni ada 1 over, not 1 over, 1 plus 1 over n. So you can see that this one is equal to that. So dia macam, benda tu datang balik. Okay, cuma awak kena recognize the form sahaja. Sama juga dengan yang ni. Dengan yang ni pula 1 plus x to the power of n. So kalau perasan dia punya kepentingan dia apa dia? Exponential tu tadi. Okay, the thing that you need to take into your lesson today is what? Your first thing is important lesson. Is the E series. Exponential. And then you also need to check your geometric series. You need also to remember your arithmetic series. Okay. And then last thing is what is P series? What does it says about P? Okay, and then you can do the comparison test. Okay, any questions so far? Okay, so kalau tak ada soalan, saya minta maaf sangat sebab tiba-tiba saya tiba-tiba saya sakit kepala kejap.